All right, in our second example, we are doing the same thing. We are trying to solve a system of equations in three variables, and we're going to do elimination 3 times, most likely. So we're going to pick a variable, pick an equation, or a variable actually, that we want to try and cancel away twice. So z's are pretty nicely kind of set up for us to do that, where I can just combine the top two equations, and our z's are going to go away. So we're looking at x plus 2y minus z equaling negative 8, and then 2x minus y plus z equaling 4. All right, we'll add the z's. Well, the z's cancel, which is what we were intending for. Put the x's together. So 3x plus y equals negative 4. And then we'll go over and maybe combine the top and the bottom equations. All right, so x plus 2y minus z equals negative 8. 8x plus y plus z equals 2. Cancel your z's away. And then we'll put our x's together. That's going to get us a 9x plus a 3y equals negative 6. Okay, so basically the reason I'm doing this is now to create two equations that now are x's and y's, and now I act as if this is what we're doing now has nothing to do with this at all, and I'm going to try to combine like terms from here, or I'm going to try to cancel out another variable. So I'm kind of starting as if now I've gone from 3 variables, 3 equations, to 2 variables with 2 equations, and now I just do elimination one more time. So if we put these things together, so we are looking at 3x plus y equaling negative 4, and we're looking at 9x plus 3y equaling negative 6. Let's try and cancel away maybe your x's. We'll multiply that by a negative 3, and that's going to get us a negative 9x plus, actually minus a 3y equaling 12. And then we didn't do anything to the second equation. Okay, and we put it together. Our x's go away, and our y's go away. So we get a 0 equals 6. So we just found a no solution. So the idea of these are, if you had 2 equations and 2 variables, you're looking at 2 lines crossing. When you're doing 3 variables with 3 equations, you're actually looking at, these are planes, flat surfaces. So you're looking for where flat surfaces cross each other. So in the example prior, we found that these flat surfaces crossed each other, and it would be like looking at a corner of a room. So you'd have 2 walls and a ceiling all kind of meeting in one spot. That coordinate would represent that spot, kind of an x and a y, and then a height to it, like an east-west and an elevation. So on something like this, you have 3 planes that don't cross each other all in one spot. And so that's going to happen. So, but if we would have found a variable here, if you would have found an x value or something like that, then you would have plugged it back into here to find the y value, and then you would have taken the x and the y to plug it back into here to find the z value. All right, and so we will do another example similar to that.